Hello there, Mr. Sutton here, bringing you the IM3-7-1 Part 1 homework solutions on Pythagorean Theorem.
For this problem, we're trying to find the missing side of this right triangle here, the top right triangle. So this one's a little tricky because when we're looking for missing sides of right triangles, the Pythagorean theorem is kind of our go-to if we have two sides of the right triangle. But we can see here that in this right triangle, the top one, we only have one side, this hypotenuse of 14. However, we do have two sides in the right triangle down below. And the side that we need in the top right triangle to get that missing x value is exactly the side that we can solve for in the bottom right triangle. So I am going to use Pythagorean theorem, a squared plus b squared equals c squared, but I'm first going to use it on this bottom right triangle to find this missing value right here, which I'm going to call h, so I have something to actually call it for the rest of this problem here. So to find h, let's plug some things in. Now in this bottom right triangle, 12, because it's across from the right angle, is our c value. So I can write 6 squared plus, again we call this h, so h squared equals 12 squared. And to get h squared by itself, I have to subtract 6 squared from both sides. So we've got 144 on the right. 6 squared is 36. So 144 minus 36 comes out to 108. And hold on a sec, before you go ahead and square root 108 to get the value of h, consider the following. We're about to use the Pythagorean theorem again to find this x value right here. And when we do that, we're going to be squaring h. So because we're already going to be squaring h as part of what we're doing later on, I'm not even going to bother finding the square root. I'm just going to leave it in this form here. So now moving on, using Pythagorean theorem again, we can say that x squared plus h squared equals our hypotenuse in this other triangle, 14 squared. And here's that h squared I was talking about. I'm just going to plug 108 directly in for h squared. So I can write x squared plus 108 equals 14 squared. And now to get x squared by itself, we just subtract 108 from both sides. 14 squared is, I just happen to know it's 196. 196 minus 108, that's going to be 88. So x squared equals 88. And we could square root both sides, but they said they want simplest radical form. So when we do that, we need to simplify the square root of 88. Well, I don't know what the biggest perfect square that goes into 88 is, but I know 4 goes into 88. So let me split this up into radical 4 times radical 22. So that's 2 radical 22. And 22 actually doesn't have any perfect squares that go into it. So this is as good as it gets. To find the missing side of this right triangle, since we've already got two sides, let's use Pythagorean theorem. A squared plus b squared equals c squared. So in this case, the c value, always across from the right angle, the c value is going to be this 50 right here. So that means 30 and x are the a and b values. So I can write 30 squared plus x squared equals 50 squared. And now I have to subtract 30 squared from 50 squared to get x squared by itself. So that's 2,500 minus 900. That's 1,600 that x squared equals. And you might know offhand that the square root of 1,600 is 40. But if not, well, now you know. So that's simplest radical form, and this problem is done. Now you might have also recognized that this was a 3, 4, 5 triangle. If so, good job. For this problem, we're trying to find this missing side here for this right triangle in simplest radical form. Since we already have two sides of this right triangle, let's use the Pythagorean theorem, a squared plus b squared equals c squared, to get that third side. So I always pick out my c side first. That's going to be the side that's across from the right angle. So that's this x side here, and that means that a and b we can write as 40 and 42 or vice versa. So I will write 42 squared plus 40 squared equals, in this case, x squared, because that's the variable they picked. And now let me add up what we have on the left side here. I'll just use the calculator for that. So 42 squared plus 40 squared, that comes out to 3,364. And now if I square root that, I need simplest radical form, but let me first check to see if it's already a perfect square. So going back to the calculator, let me do square root. So, and then let me just go back here and yank that input from before. 3364. That comes out to, exactly 58. Well, can't get any simpler than that, right? For this problem, I want to find the missing side of this right triangle. So let me use Pythagorean Theorem since I already have two sides of a right triangle. That's a squared plus b squared equals c squared. And the c value in this case across from the right angle is going to be this x right here. So that means a and b are these other two sides that we actually know. So I can write 56 squared plus 33 squared equals x squared. And then let me use the calculator to figure out what we actually have on the left side. So 56 squared plus 33 squared comes out to 4,225. So I'm supposed to put my answer in simplest radical form. So let me square root this on the calculator to see what x is, and hopefully it's a whole number. If it comes out to a decimal, I'm going to have to go back and actually break this down a little bit more. But going back to the calculator, let's just do square root of, and let me just go up here and yank my output, 4225, and it comes out to exactly 65. Well, I believe that is simplest radical form. There's our hypotenuse. For this problem, I want to find this missing side over here for this right triangle. Since I've already got two sides, I can use my Pythagorean theorem, a squared plus b squared equals c squared. So for a, let me use 11 down here, the base, so 11 squared, and then b will be the other non-hypotenuse side of x, so x squared. And then c, that's always going to be the side that's across from the right angle, the hypotenuse. So that's 13 squared. All right, well, I have to subtract 11 squared from 13 squared to get the x squared by itself. So that's 169 minus 121. I believe that is 48 that x squared equals. And now I'm going to square root both sides. Now they want simplest radical form, so the square root of 48, I can split that up. That's going to be my biggest perfect square that goes into 48 is 16. 16 times 3, so I have radical 16 times radical 3, which I can simplify to 4 radical 3. For this problem, let's say that you're flying a kite with a string 10 feet long. As the wind picks up, the kite flies over your friend who's standing 6 feet from you. How high above your friend is the kite flying? So this is actually a triangle situation. The three parts of the triangle are you, your friend, and the kite. So let's draw a triangle. And so let's say that you're over here, your friend is over here, and the kite is up in the air right here. They said that our string was 10 feet long. So we're going to label parts of this triangle now. That means that this side of the triangle between you and the kite is 10 feet long. And they said your friend is standing 6 feet away from you. So that's going to be 6 feet on the ground right here. And we want to know how high above your friend the kite is flying. So we're looking for this distance right here between your friend and the kite. And presumably this is going to have to be a right triangle because they're asking distance above, so that's kind of a perpendicular sort of distance they're asking for. Straight up distance. So to do this, since we do have a right triangle, we can go ahead and use our Pythagorean theorem, a squared plus b squared equals c squared. And in this case, the c value, that's going to be this longest side here. That's going to be the kite string. And then that's 10. And then a and b are going to be 6 and x or vice versa. So I'll write 6 squared plus x squared equals my hypotenuse 10 squared. And now let's see here. We can do 100 minus 36 to get x squared by itself. So that's going to be 64. And then if I square root both sides, I get x equals 8. And this is a real life problem with real life units. So that's going to be 8 feet. So that's how high above your friend the kite is. On this real life problem, in baseball, the distance of the paths between each pair of consecutive bases is 90 feet, and the paths form right angles. We want to know how far to the nearest tenth the ball needs to travel if thrown from home plate to second base. So this one, after you maybe play that Abbott and Costello skit about who's on first, this one is good to draw a picture for. So here's a baseball diamond, and we're saying between our bases, which are the vertices of this diamond, we've got 90 feet. So each of these sides is 90 feet, and they said that we have right angles between the paths. So we want to know how far it is basically from home plate, which is usually down here, to second base, which is across the diamond. So this distance here. which I'll call x. And we see here that this is actually a right triangle problem at this point. We've got two sides of a right triangle. We're looking for the third side, the hypotenuse specifically. So this is a good one for the Pythagorean theorem. A squared plus b squared equals c squared. So a and b are going to be these two legs that are not across from the right angle. So we have 90 squared plus 90 squared. And then c, of course, is that hypotenuse of x, so x squared. And let me just add stuff up on the left side. I'm going to use the calculator to do this, not because I can't do it without a calculator, but honestly because they want this rounded to the nearest tenth. So I'm probably going to have to use the calculator anyway. Might as well start now. So adding those 90 squareds together, we get 16,200. And then to get the value of x, all we have to do is square root that quantity. So back to the calculator. Let's do second x squared to get my square root. And then let me just arrow up to grab that output from before. Press enter. Press enter again. And it comes out to about 127.3. And that's going to be in feet.